All right, here's the first part of our 3H notes. We're going to use some matrices to solve some three variable systems right here. First thing we're going to talk about is Gaussian elimination. Here's a really good YouTube video that sort of goes over how to do Gaussian elimination if you want a little extra refreshment or if you want to hear a voice that's not mine. There are some more complicated ways to do Gaussian elimination. I'm going to try to make it really, really simple. And so the simplest way to do it is this. We're going to create a matrix, okay, with our numbers, our coefficients, and our final numbers there. And we're going to get all the bottom left numbers in the corner equal to 0. Bottom left corner. Okay. Now, what's going to happen when we get those numbers equal to 0 is it allows us to solve for z. Okay, and then we'll get a number for z. Okay, and then we go to our second row and we plug in z to find y. Okay, and then once we find z and we find y, then we can go to any one of our equations and solve for x, because now we have numbers for all these, for z and y. Okay, so that's sort of the process here. We're going to get the bottom left corner numbers equal to 0. It'll allow us to solve for z, and we can go back to our second row, plug in z, solve for y. Once we know z and y, we can do any of these equations to substitute and find x. Okay, so what we're going to create is we're going to create what's called an augmented matrix right here. So this augmented matrix that we have, we're going to have 3, 1, negative 2. Those are our coefficients. And we're going to put a bar right here to sort of divide it with our final number 10. Okay, then we're going to have 6, negative 2, 1, negative 2, because 6, negative 2, 1, negative 2. And then on the bottom, we'll have 1, 4, 3, 7. The goal of this is to do some elimination to get this, the 6 equal to 0, the 1 equal to 0, and the 4 equal to 0. We want to get these bottom three numbers equal to 0. Once we do that, we'll be able to isolate. We'll have this number right here times z equals that number right there, and then we can easily solve for z. Okay, and we're going to do elimination with this the same way we did elimination before. It's actually easier doing it with a matrix like this. That way we don't have to worry about the variables and all that other stuff. And so we want to work second row first, and then down to the third row. Okay, so we want to work second row first, and then we want to go to the third row. All right. So for our second row, we need to eliminate the 6 and make that a 0. Okay. We could work the third row or the first row. Doesn't really matter. However, I think it would be easier to multiply. We can multiply the first row by 2 and subtract that from the second row. Okay. Subtract that from the second row. And then that'll make the 6 equal to 0. So if we have row 2 and we minus 2 row 1, we can rewrite our row 2. Okay, so looking at row 2, we have 6, negative 2, 1, negative 2. Row 1, if we double row 1, we have 6, 2, negative 4, 20. Okay, because we distributed 2 through each of those right there. So we're going to subtract these. All right, so 6 minus 6 is 0. Negative 2 minus 2 is negative 4. 1 minus negative 4 is 5. Negative 2 minus 20 is negative 22. Okay, so what's going to happen is this is going to be our new row 2. So our new row 2, we have 0, negative 4, 5, negative 22. Okay, so now we only have to make two more zeros. We got to make this 1 a 0 here, and we got to make this 4 a 0 there. All right, so we need to make this 1 a 0. And unfortunately, we can't work row 3 with row 2 because, see, row 2, the coefficient of that is 0, and there's nothing that we can multiply there um, to make that 1 equal to a 0 and to eliminate it with that. We can't do that, okay? We can work row 3 with row 1, though, okay? So I have row 3, 1, 4, 3, 7, and row 1, 3, 1, negative 2, 10. So in order to match these up, all we have to do on row 3 is we multiply row 3 by 3. Now we have 3 here and 3 there, okay? So what we'll do is we'll multiply row 3 by 3, and we'll subtract that from row 1. Okay, so now we have 3 row 3, which is going to be 3, 12, 9, 21. So we're multiplying 3 all through this row. On top, we have 3, 1, negative 2, 10. We're going to subtract these bad boys. So we get 3 minus 3 is 0, 12 minus 1 is 11, 9 minus negative 2, also 11, 21 minus 10 also happens to be 11, coincidentally. Okay, so now we can replace our third row with 0, 11, 11, 11. Now, the only thing that we have left to do here, ladies and gentlemen, is to get this 11 equal to 0. Okay? Get the 11 equal to 0. Now, we have to work with row 3 and row 2 here because, if we multiply, the top row by 11 or whatever and subtract, now that'll change that 0. We don't want to change that 0, okay? So we need to work within these two rows right here to keep these zeros intact. And so we need to match up these two things right there, okay? So what we're going to do is we have to take negative 4 and 11, and we have to get them to be the same coefficient. The least common multiple between those two is going to be 44. So we'll multiply this row by negative 11 and multiply this row by 4. Okay. So we'll take row 3, or 4 row 3, minus negative 11 row 2, and we should be good to go. Okay, so looking at 4 row 3, multiply row 3 by 4, so 4 times 0 is 0, 44, 44, and 44. And again, we need to work row 3 and row 2 on this last step here, ladies and gentlemen, because I got to keep these zeros. Okay, so I can't work row 3 with row 1 anymore. All right, now we're going to multiply negative 11 by row 2. So negative 11 by row 2, so we have negative 11 times 0 is 0. Negative 11 times negative 4 is 44. Negative 11 times 5 is negative 55. Negative 11 times negative 22 is going to be 242. All right, so now we'll subtract these bad boys. And so now we have 0 still. 44 minus 44 is 0. 44 minus negative 55, which is 44 plus 55 is 99. And then 44 minus 242, which is negative 198. So this will replace our row 3. So now we have 0, 0, 99, negative 198. So what this does now, guys, it simplified our bottom row to where it eliminated our x's and our y's. Okay, so going to our bottom row, all we have is this: 0x plus 0y plus 99z equals negative 198. So we have 0x plus 0y plus 99z equals negative 198. So now those are gone. So we have 99z equals negative 198. Well, we can solve for z, right? Z can be negative 2. It's divided by 99. Now we go back to our second row. Okay, our second row, the x is eliminated. We just have y and z. Well, y and z is two variables, but we already know z. Okay, so looking at this equation, we have negative 4y plus 5z equals negative 22. But we know z. Z is negative 2. So we have negative 4y 5 times negative 2 is negative 10. So negative 4y plus negative 10 equals negative 22. Well, here, we can go ahead and solve for y. All right, move the 10 over. So we have negative 4y equals negative 12, which makes y equal to 3. All right, now we know z and we know y. So we have numbers for those. Okay, that's the whole point of doing it this way, to getting those zeros. Okay, we have numbers there. Okay, so now we get z and y are numbers. Now we can go back to any one of these equations and solve for x. Any one. We can use the top row here, 3, 1, negative 2, 10 if we want to. We can go back to any of these if we want to. Let's just go to our top row for kicks and giggles here. So we have 3x, right? Plus y, which is 3, minus 2z equals 10. Okay, so 3x plus 3 minus 4, which is really going to be 3x plus 3 minus 4. Oh, plus 3 plus 4, excuse me. 3x plus 3 plus 4, 3x plus 7 equals 10. All right, we solve this bad boy out, and we get 3x equals 3, x equals 1. And there you have your thing, okay? So it's just elimination on steroids, if you will. Okay, it's like elimination on steroids. I'm going to do this next one for you guys here as well because it may be a little bit complicated. And so I want to try to simplify it, and hopefully you guys can watch and get the repetitions. If you feel good about this already, then go ahead and try it yourself without the video. If you need to see one more done, here it is. And I also encourage you to go click the link that I put on the top of the note sheet as well for another good video to sort of help you guys out with this. So here we're going to create our augmented matrix. So we have 2, negative 5, negative 1, 17. We have 1, 1, 3, 19. And we have negative 4, 6, 1, negative 20. Put a bar through there in order to sort of divide those numbers out. All right, so all we did is sort of rewrote this system of equations as a matrix, make sure the z's, y's, and x's are all lined up, which they are. It's good. Okay. So again, what we're trying to do is we need to make this a 0, this a 0, that a 0. So we'll start with row 2. Okay. Well, row 2, we have a 1. Up here we have a 2 or negative 4. We could use either one of these. I think it'd be easier to just multiply row 2 by 2. And that way we can just eliminate it with row 1. Okay, so what we'll do is we'll do 2 row 2 minus row 1. Okay, so multiply row 2 by 2. So we have 2, 2, 6. 19 times 2 is 38. Row 1, we have 2, negative 5, negative 1, 17. Subtract them out. 2 minus 2 is 0. 2 minus negative 5 is 7. 6 minus negative 1 is also 7. 38 minus 17, I believe, is 21. All right, so we took care of this row. So now we got 0, 7, 7, 21. Okay, now for the third row. Okay, in order to work here, we have a negative 4 here. Can't really work the negative 4 with the 0 to eliminate that. So what we'll do is we will work it with the first row. The first row has a 2. So that'll be pretty simple to fix that. All we got to do is multiply the first row by negative 2. Okay, so now to get that negative 4 by itself, we'll multiply the top row by negative 2. So we'll go row 3 minus negative 2 row 2. Negative 2 row 1, excuse me. All right, so now we have negative 4, 6, 1, negative 20. Row 1 times 2 is we have negative 4, 10, 2, negative 34. We'll subtract these. So negative 4 minus negative 4 is 0. 6 minus 10 is negative 4. 1 minus 2 is negative 1. Negative 20 minus negative 34, which is negative 20 plus 34 is 14. So now we redo this thing here. We have 0, negative 4, negative 1, and 14. Almost done. All right, so now we got to get that negative 4 here equal to 0. And we have to work it with the second row, okay? Again, we can't work it back with the first row because now that'll change this 0 to something that's not 0, and we don't want to do that, okay? So we have to work row 3 with row 2 here in order to keep these zeros, okay? So negative 4 and 7, the least common multiple is going to be 28. So we can multiply this row on the bottom by 7 and multiply the second row by negative 4, okay? So we'll go 7 row 3 minus negative 4 row 2, okay? So row 3 times 7, 7 times 0 is 0, 7 times negative 4 is negative 28, 7 times negative 1 is negative 7, and then 14 times 7, I want to say it's 98, yeah. All right, and then we're going to subtract it by negative 4 row 2. So negative 4 times 0 is 0. Negative 4 times 7 is negative 28. Negative 4 times 7 is negative 28. And then negative 4 times 21 is negative 82. All right, and so now we can go ahead and subtract these bad boys here. So 0 minus 0 is 0. Negative 28 minus 28 is 0. Negative 7 minus negative 28. Negative 7 minus negative 28 is 21. Then 98 minus negative 82. 180. Check that. It should be 84. I'm sorry. 4 times 21 is 84. All right, so we have 7 row 3 minus 4 row 2. And we have 21z equals 182. We're going to get a decimal for z, but that's okay. So 182 divided by 21 is going to be z. All right, so it's going to be 8.66 repeating. All right, and then once we have z, we can go back to y here in the second row. Get rid of this stuff here. So going to our second row, we have 0x, 7y, plus 7z, which is 7 times 8.66 repeating, equals 21. All right, so then we solve this out. 7y equals 21 minus 7 times 8.66 is repeating. So 7y is going to be negative 39.666 repeating, which makes y equal to negative 5.66 repeating. Now we have y and z, then we can go solve for x. Okay? So that's that. That's a Gaussian elimination right there, getting those 3 bottom things equal to 0. And we're set to go after that. So try the next 3 problems, 4 problems out there if you need to. Probably only going to get 1 or 2 done the rest of this period, but that's okay. Let me know if you have any questions, and best of luck.